So I'm going to just label these equations A and B so we can refer to them quickly here. You could either use elimination, the addition method, or the substitution method here. I think it's probably easier to use the addition method, but substitution would still definitely work. When you guys went about this, how did you approach this problem? What did you guys do? Okay, so let's go with elimination. Which variable did you get rid of, x or y? Okay, so how did you get rid of the x's? Okay, so when you multiplied equation A by 3, what'd you get?
15x plus 9y equals negative 21.
Perfect. 15x plus 9y equals negative 21. You multiplied equation B by negative 5 to get?
I got negative 15x minus 10y equals 20.
Okay, perfect. And now we do have the x that will cancel out when we add the equations. So 15x and negative 15x cancel. 9y and negative 10y?
Negative y.
Negative y. Some might be easier to think of it as negative 1y. Equals?
Negative 1.
Negative 1. So now to solve for y, we do have to get rid of that negative or negative 1. We'll divide by negative 1. Y equals 1. What's next?
So I took that 1 and I plugged it into equation B to solve for x.
Okay, so we put it in, replaced y in that second equation, in equation B, with 1. So 3x plus 2y becomes 3x plus 2 times 1 equals negative 4. And now we have to combine and then solve. Combining 2 times 1 is 2. What's next?
Subtract 2.
Subtract 2 to get?
3x equals negative 6.
And then?
Divide by 3, x is negative 2, so the solution is negative 2, 1.
Perfect. You divide by 3 to get x is negative 2. So yes, our solution is negative 2, 1. Any questions on that? Okay, perfect. When we left off yesterday, we were starting to look at some word problems. So we're going to start off with just some number problems, some sentence problems. And I'm just going to give you find two numbers whose sum is 60 and difference is 24. So we have two numbers. I'm going to let those two numbers be x and y. And we have to describe the relationship between those two numbers in two different ways. The first one is the sum. What does sum mean? Addition of. So that means x plus y equals 60. The next is the difference. What's the word difference mean? Difference means subtraction, right? Now we don't know whether it's x minus y or y minus x. It doesn't matter. What we're going to do is this. We're going to define x to be the larger number and y to be the smaller number. So what that means is we can do x minus y because we're getting that positive result of 24. Now this one's set up very easily to solve with that addition method. If we simply add the equations here, x plus x makes 2x. Y plus negative y Cancels out, equals,
84.
perfect. 60 plus 24 is 84. And now we can very quickly solve for x by just dividing by 2. So x is 42. Now we can go back to either of the other equations to find y. I'm going to go to the top one, replace x with 42. 42 plus y equals 60. And now we'll solve for y. We're going to subtract the 42 to get y equals 18. So our two numbers are 42 and 18. Make sense? That one's pretty simple to set up when you do it that way. We might have other problems like this. Pat sells 3 times as many computers as Sam. They sell a total of 60 computers. How many did each person sell? How many did each sell? Well, normally I'd use P and S for Pat and Sam, but S's look an awful lot like 5s when I write them. So I'm going to just label this Pat. I'm going to let Pat sales be X, and Sam, let Sam's sales be Y. I know Pat sales plus Sam's sales has to add up to what? 60. They sold, should put a Y on that, they sold a total of 60 computers. But what else do I know?
Pat sold 3 times as many as Sam.
Perfect. Pat sold 3 times as many as Sam. So X, which stands for Pat, is equal to 3 times Sam. So 3 times Y. This system would not be so easy to use elimination on. I mean, you could use it or the addition on. You could do it, but it wouldn't be quite as simple. But this system is actually very simple to use substitution on. I'm going to replace the x in this problem with 3y, because x equals 3y. So that top equation, instead of x, I have 3y plus y equals 60. What am I going to do next there? Combine them. 3y and y makes 4y. Wonderful. And then divide by 4 to get y equals 15. Now remember what y was. Y was Sam. So Sam sold 15. We still have to solve for Pat because we're asked how many did each sell. To find x, we go back into this equation. X equals 3 times y, which will be 3 times 15, or 45. So Pat sold 45. Time for you guys to try some. Let's say that Alex sells 3 times as many TVs as Peyton. If Alex sold 12 more than Peyton, how many did each sell? I'm going to give you a couple minutes in your notes to work that one out. See what you come up. So we have Alex and Peyton. Let's let X be the number that Alex sells and Y be the number that Peyton sells. What are our relationships here? What do we find? What do we have?
Is one of them x equals 3y?
X equals 3y because Alex sells 3 times as many as Peyton. That's perfect. What's the other one?
Is it y equals x plus 12?
Y equals X plus 12 would work. Or you could put X minus Y equals 12. Either one would be... Actually, something's a little backwards on this one. It's not Y equals X plus 12 because it wasn't Peyton that sold more. It was Alex, which gives you X equals Y plus 12. Alex sold 12 more. So Alex equals Peyton plus 12. From here, you could use the addition method. But again, this is actually perfectly set up for substitution. If X equals 3Y and X equals Y plus 12, 3Y equals Y plus 12. What would we do from there? Subtract the Y. To get 2Y equals 12, and then divide by 2 to get Y equals 6. So remember, Y represents which one? Peyton. So 6 is Peyton. How do we find Alex?
3 times 6.
X equals 3 times Y, or X equals 3 times 6 is 18. Very good. So Alex is 18. Any questions there? So we might have Kim sells 13 more items than Stacy. They sold a total of 91 items. How many did each sell? How many each? Looking at these, there's a natural way of defining our variables. There's a couple of ways we could do it. It's just one way is a little bit more natural than the other. Which one would I want to let be X? Kim's or Stacy's sales? Typically, I try to let the smaller one be X. So in this case, which one's going to be the smaller one? Stacy. So Kim, we'll let Kim be Y, but the relationship between those is going to be Y equals
X plus 13.
X plus 13. Would have it made a difference if we defined them the other way? No, it wouldn't have. It would be X equals Y plus 13, and that'd be fine. My brain just tends to like having X be the smaller one for some reason. What's the other relationship between them?
x plus y equals 91.
X plus y equals 91. Now this one we could do substitution very simply, just like we have in the last several problems. But to shake it up a little bit, I am going to do addition here. But I have to have them in order. Right now, these are not lined up. What I'm going to do is this. I'm going to keep that top equation just like it is. Now you might be wondering, well, that doesn't look right. And it's very different than what we've done so far. This bottom equation, to make sure it lines up, I'm going to subtract x from both sides. And I'm going to get y equals 91 minus x, or negative x, plus 91. Now what you'll see is, even though this isn't lined up the way we're used to, it is still lined up. It's not x's, then y's, and then equals, and then the constants. It's different. Now it's y's, and then equals, and then x's, and then the constants. But it's still lined up. And when it's lined up like that, we can still add the columns. So y plus y is 2y. X plus negative x disappears, cancels out. 13 plus 91 is 104. And then, of course, we'll divide by 2 to get y equals 52. So we have y equals 52. That's Kim. To get Stacy, I can use either equation. I'm going to use the top one up here. Put 52 in for y equals x plus 13. How do I find x?
Minus 13.
We subtract 13. Very good. So we get, 39 equals x. So Stacy's sales is 39. What do you think? Not too bad? You might recall the formula for the perimeter of a rectangle is P equals 2L plus 2W. We have done rectangle perimeter problems, and technically those were systems of equations. We just kind of fudged it so that the system, we worked around having to use systems of equations in them. But technically, those involved a system of equations. If I give you the length of a rectangle is 6 times the width, the perimeter is 322 feet. Find the length and the width. So we have here two equations. The first is just this perimeter formula with 322 feet going in for P. 322 equals 2L plus 2W. Our other equation is this relationship between the length and width. What equation is going to describe that?
Would it be L equals 6W?
L equals 6W. The length is 6 times the width. So now what do we do with that? Well, we can solve this by substitution, right? 322 equals, instead of 2L, we're going to write it as 2 times 6W plus the 2W. Now what? We do the 2 times 6W, which is 12W plus 2W. Then what? Combine like terms. 12W and 2W make 14W. And then?
Divide by the 14 and you get 23.
23. Exactly?
Yep.
Okay. So W equals 23. Well, we need to find both the length and the width. The width is 23. That unit would be feet. To find the length, what do we do?
6 times 23.
Yeah, L equals 6W, so L equals 6 times 23, otherwise known as?
138.
138. Very good. I want to see how you guys adjust on your feet to these. So I'm going to give you a similar problem, but a little bit different form. The length of a rectangle is 7 more than the width. The perimeter is 434 inches. Find the length and width. I'll give you a couple minutes to try that one, then we'll go over it. So our formula for perimeter, P equals 2L plus 2W. That's going to become what? Yeah, 434 equals 2L plus 2W. Good. What's our second equation going to be? L equals W plus 7. Good. W, the length is 7 more than the width, so L equals W plus 7. What do you do from there? We could substitute it in. So this is going to be 434 equals, instead of 2L, it's 2 times W plus 7 plus 2W. What next? Distribute the 2 to get 2, perfect. 2W plus 14 plus 2W. And then combine like terms. So 434 is going to equal 4W plus 14. And then subtract 14. 420 equals 4W. And then divide by 4. You got it. 105 equals W. So where do we go from there? W equals 105. We have to find L. So L equals 105 plus 7, which is 112. Now this system right here could have been solved with addition as well. Let me show you what I mean. we have that 434 equals 2L plus 2W. In this equation here, I could have subtracted W from both sides and then changed the order. So I would have got 7. This would have been L minus W. And so to use the addition method, all I would have had to have done is multiplied the bottom one by 2, and we could have gone from there. We would have had a positive 2W and a negative 2W. So many of these could just as easily be solved with either method, the substitution or the addition method. Some of them just, they look more apparent that substitution is easier, or others look more apparent that the addition method is easier. So let's take a look at something just a touch more complicated then. Let's say that, we'll go back to Kim again. Kim sells t-shirts for, oh, let's go $12. And hats for $9. Kim sells 3 times as many hats I gotta reword that. Kim sells 3 times as many hats as t-shirts for a total of, oh, let me make this work out well here. $468. How many of each did Kim sell? This problem has an extra layer of difficulty in it. So what we're going to have is we're talking about t-shirts and hats. But we actually got a couple of different things that we're describing in each of them. The first thing, what we're going to use our variables to describe, is the number sold. I'm going to let X be the number of t-shirts, Y be the number of hats. Just going to throw them in there, X and Y. But we're not given the total number sold, we're given the total dollar amount raised, total revenue. So we need to work with that number. Revenue, total dollar sales, is the price times the number sold. What's the price of the t-shirts? $12, and there were X sold. So 12 times X, or 12X, is the dollar sales from t-shirts. What's it going to be for hats? $9 per hat, so 9Y, 9 times Y, is the dollar sales from hats. What do we know about those two numbers?
It's got to equal 468.
Adds up to 468. So 12X plus 9Y equals 468. That's one equation. What's our second equation going to be?
3x plus y, maybe something like that.
Kim sells 3 times as many hats as t-shirts. So hats is Y. Hats equals 3 times the t-shirts, right? So hats is Y equals 3 times X. So you gotta be very careful with that one. Well, here's one I'm not even gonna try to argue for elimination, for addition. This one's definitely a substitution problem. So I'm going to substitute, I'm going to replace y here with the 3x. So 12x plus 9y becomes 9 times 3x equals 468. Now what?
Distribute the 9.
Multiply by the 9, yes. 12x plus, what's 9 times 3x?
27x.
27x equals 468. What's next?
Combine the x's, get 39x.
Perfect. 12x and 27x make 39x equals 468. And then?
Divide by 39, you get 12.
Divide by 39, we get x equals 12. Now we have to remember, first of all, what x stands for, and we have to make sure we've answered the question. So that's why I write things down like this. X is 12. That stands for the number of t-shirts sold. There were 12 t-shirts. The question was how many of each, so we got to find y. Y is 3x, so y equals 3 times 12, or
36 hats.
36 hats. Any questions there? Well, what if there's a slight difference in this? So Kim still going to sell t-shirts. Was it 12 bucks? Yeah. T-shirts for $12 and hats for $9. Kim sells 48 items for $468. How many of each did Kim sell? Once again, I'm going to give you guys a couple minutes to see what you can set up here and see what you can come up with. This one actually definitely has an extra little level of difficulty to it. And it comes from the relationship here. But let's look at the number sold first. Again, I'm just going to let one of them be x and the other y. So let the number of t-shirts sold be x, number of hats sold be y. Want to know the dollar sales now. The dollar sales is the price times the number sold. Well, t-shirts are still $12 each, so that's 12x. Hats are still $9 each, so that's 9x. Giving us the equation 12x, sorry, not 9x, 9y, I should say. So 12x plus 9y equals 468. That's actually exactly the same first equation we had last time. What's the second equation going to be, though?
Would it be x and y is 48 items?
X plus y equals 48. Very good. Here we could use either method. We could use substitution or we could use addition. We haven't used addition for a while, so I'm going to use addition. 12x plus 9y equals 468. I'm going to leave exactly like that. This bottom equation I'm going to multiply by negative 9. Negative 9 times x is negative 9x. Negative 9 times y is negative 9y. Equals negative 9 times 48 is negative 432, I believe.
Yeah.
And now we're set to do our addition. $12x and negative 9x make 3x. 9y and negative 9y add up to 0, so they cancel out. Equals 468 plus 432. 468 plus a negative 432, I should say, is 36. What's our next move? Divide by 3 to get x equals 12. So there's 12 t-shirts sold. We still need to find the hats. We know that x plus y equals 48. So I put 12 plus y equals 48. What do I do from there? Subtract 12 to get y equals 36. So you can see it's actually the exact same problem we just did. It was just presented in a different format. Any questions there?
Well, this is kind of like what we were doing a few weeks ago with those word problems,
Exactly.
with the solutions.
Yes. And the word problems we did a few weeks ago is exactly the same problems. It's just we hadn't talked about systems of equations yet. So we actually did substitution when we set up the problem. Like here, let's go back up to this one. Instead of doing x and y, we would have said x and 3x. Well, that was just y equals 3x. So we did the substitution as we set up the problem. But with the systems of equations, it's a little bit more work, but it makes a lot more sense to set them up that way.
Yeah, okay.
Okay, so, in fact, we did these mixture problems just about a week and a half ago. Same type of thing applies there. If I want to know, find the amounts of 17% and 38% solutions to mix to create 360 milliliters of 31% solution. We solved these before without systems of equations, but we were kind of circumventing the system by doing some different things when we set them up. But here we are mixing 2% to get a result. The 2% we're mixing, the 17 and 38. The result we hope to get is 31%. If you look at the amounts, it looks like we only have one amount given, and it's true, we only do have one amount given. What is it? 360, and that is the result. So I'm going to let x be the amount of the 17% and y be the amount of the 18%, or the 38%, I should say. So x is the amount of the 17, y is the amount of the 38. Well, we have our first equation right here already. X plus y has to add up to 360 milliliters. X plus y equals 360. Our second equation then comes from that solution concentration equations we did. 17% times x is 0.17x. 38% times y is 0.38y equals 0.31 times 360. So before I actually start to solve this, my ultimate system, I'm going to multiply the 0.31 times the 360. So it's 111.6. And of course, my other equation is going to be x plus y equals 360. I have options here. This is where the other day we discussed, what do you do when you got these ugly decimals in here? Well, this one doesn't necessarily apply to that because the decimals are only in one problem. So I could multiply this bottom equation if I wanted to. I could multiply it by like a negative 0.17 if I wanted to, and it would work out. I could cancel out the x's. My x disappeared here. That's 0.17x. So that dividing, like I showed you the other day, that really only applies. You only have to really do that if both equations have decimal coefficients or fraction coefficients. So I'm going to go ahead and do that. I'm going to multiply that bottom equation by a negative 0.17. So my top equation is going to stay the same. 0.17x plus 0.38y equals 111.6. On the bottom equation, negative 0.17 times x is negative 0.17x. Negative 0.17 times y is negative 0.17y. Negative 0.17 times 360 is 61.2. Negative 61.2. Now I can do the addition. First of all, any questions as to where those equations came from? So the 0.17x and the negative 0.17x add up to 0. 0.38y and negative 0.38y is 0.21y. 111.6 plus a negative 61.6 is 50.4. And then I'm going to divide by 0.21. 240, very good. Y equals 240. So let's go back up and make sure we know what that is. Y was the amount of the 38%. So that's 240 milliliters. To find the 17%, x plus y becomes x plus 240 equals 360. We subtract 240. Get x equals 120. So we got 120 milliliters of the 17% and 240 milliliters of the 38%. Any questions? Now I could go on and on with the word problems involving systems of equations, but I'm not. I promise you to give you some time. We have about 20 minutes right now to review for test 1. What I'm going to do is I'm just going to kind of list topics that are going to be on test 1. Test 1 in the textbook is basically chapters 1 through 4. We are pretty much going right in order in the textbook, so if you go up to systems of equations, I'm in the table of contents, that's where we're at. So things to study, topics that will be fair game for the test. First of all, have you guys had a chance to look at the study sheet yet? Okay, so the study sheet, if you can complete that study sheet, you are good to go. But I will say this, the study sheet contains quite a few more problems than the test does. The test itself, usually I try to get to about 30 questions. It looks like I had 30 questions on the test. So the test itself will be 30 questions. That study sheet ended up being like 120 questions or something like that. So no, it's not going to be nearly that painful. As I had said, I just did the answer key for the test yesterday. It took me right around 18 to 20 minutes. So I usually figure students will take about 3 times as long as I do. So about an hour is what I'm estimating the test to take. You will have the full class period, and if you need more time beyond that, you do have unlimited time on the test within reason. You do have to be done before WITC closes on Monday. So that's the big thing. And like I said, it has to be done in one session. You can't get up and go away for half an hour and come back to it is all. You can take bathroom breaks. Yeah, you can take bathroom breaks and stuff like that. But yeah, I would like to have you back within 10 minutes for breaks.
And that's a 1 attempt?
This is only 1 attempt, and this is going to be paper and pencil. So when I do take these tests, once I grade them and give them back to you, I do give you the opportunity to redo the problems you got wrong. I'll explain that more once I get them back to you. Chances are I won't have them back to you by class on Tuesday, just because the system of scanning and faxing them, I probably won't get them until Tuesday morning. So it probably will be Wednesday or Wednesday at the earliest I would have them graded. I will definitely have them done by the following Monday, but I'll try to have them done for that Wednesday's class. So looking at the study sheet, did you guys have any questions off the study sheet that you had questions with? Okay, so topics that you need to be able to work on. Oops, did you have some questions on it, Ezra?
Looking real quick here.
Okay. So I'll start listing some topics for us. Some topics, one of the big ones, order of operations. But it could be order of operations with, fraction bars in it, absolute value symbols in it. Know how to use the absolute value symbols within the order of operations. Negatives, integers within the order of operations. Any questions on those that you're worried about? Anything looking at that you're not sure of?
I get the concept on those. I just have to go slow and not make mistakes.
The biggest thing with those, I know I even start at this point in the course, I start to take some shortcuts with order of operations, and I start to do 2 operations at the same time. The biggest thing I can recommend on those is go back to the basics, pretend you don't know the shortcuts, and just do 1 step at a time and rewrite the rest of the problem. I'm going to try not to give you any huge monstrous problems that if you rewrite it at every step, it's going to take up a page and a half or anything like that. I'm not going to be quite that mean to you. So you should be able to rewrite them and just be very meticulous and careful on them. Because you're absolutely right. Where I see people make mistakes is they try to save time and skip steps. Exponents. Again, exponents with integers. Exponents with fractions. Exponents, of course, include powers. We really haven't covered much, but roots are a part of exponents.
We had the equations on there that we might need, like point slope and slope intercept, or should we try to remember those?
You should try to remember those. I will allow you, that's something I should announce. You are allowed to use a note page on the test. So I'll make sure I send out an announcement through Blackboard since there's so many people gone. One page, you can use front and back. So yes, you are allowed that. I have in the past allowed some groups to use their books and notes on the test, but the trade-off for that was then I put a time limit on it. So they had to be done, not for this particular class. This is the first time I've taught this class for Nicolet. But when I've taught intermediate algebra for other institutions, they had a time limit. They had to be done in 2 hours. And most people prefer to do a note sheet and have unlimited time. We'll see after this test. You guys might ask me to change it. We need to be able to translate words into expressions. This was things like, 3 times the sum of a number and 6, or 7 less than 5 times a number is 22. So you need to know which ones are equations and which ones are just expressions. And you need to know which ones are inequalities. Very subtle difference between 7 less than 7 less than 3 times a number. And 7 is less than 3 times a number. Seven less than 3 times a number. 7 less than something means 7 is being subtracted from it. 3 times the number would be 3x or 3n, whatever variable you want to use. 7 is less than 3 times the number means 7 is less than 3x, like that. So a very subtle difference. Make sure you're very careful with those. Evaluating expressions. This is things like 7x squared minus 5y. And evaluate it for x equals negative 5 and y equals 3. Put the numbers in, do order of operations to get the value. Solving equations of all forms. So simple equations, equations with fractions, equations that are fractions, and so on. Linear inequalities in one variable. So linear inequalities in one variable, that's where it's only one, it might be 3x minus 7 is less than or equal to 11. And you had to solve that. There's two ways that we know how to express that answer. One is on a number line. The other is solution set notation. So if I were to solve that at 11, 3x is still less than or equal to 18. And divide by 3, x is less than or equal to 6. I could put that on the graph. Less than or equal to, it's a closed dot, solid dot. Less than goes to the left. Or in solution set notation, all right, this is x such that x is less than or equal to 6. It's just that simple. And of course, those inequalities can get very complex. Remembering to flip the symbol if you multiply or divide by a negative. You have linear inequalities of two variables. That's where we graph. We can have a solid line or a dotted line, shade one side or the other. Those we've done recently, so those shouldn't be too far out of your memory. Graphing lines. Y equals 7x minus 2, 3x minus 2y equals 8, y equals negative 4. Any equations of those forms, being able to graph their line. Any questions so far on any of these? Now, I'm going to ask you to find equations. I will not specify whether you use slope-intercept form or point-slope form. You are free to use either form if you want, whichever one makes the most sense to you. Find the equation if I give you the slope and y-intercept. Of course, that would be almost too easy. Find the equation if I give you the slope and a point on the line. Find the equation if I give you 2 points. Find the equation if I tell you it's parallel to y equals 2/3 x minus 7 and through a point like 6, negative 1. Or the same thing if I tell you it's perpendicular to an equation and through a certain point. Remember, when I say it's parallel to this equation, the only thing I want out of that equation is its slope. The 2/3 is all that matters, so that we know that the line we're looking for has a slope of 2/3 and it goes through that point. If it's perpendicular, still all I want out of that equation is the slope of 2/3. The perpendicular, remember, is going to be the opposite reciprocal, negative 3/2, and of course still through that point. Any questions so far on those?
So you don't want the full equation, you just want the slope on those?
I would still want the full equation, but all you need out of this equation is the slope.
Right.
You're going to use that slope then to write the full equation for this point. But yeah, the rest of this equation is junk. All that we really need out of that equation is the slope, and that's what we're going to use for the rest of the problem.
You want to run through that perpendicular one there that you have?
Sure. Let's find the equation of a line perpendicular to y equals 3/4 x minus 7 and through 6, 5. So again, from this equation, all I care about is the slope. That slope is 3/4. For the perpendicular, the slope's going to be -4/3. The simplest way to find an equation would be to use point slope form. So through that point, it'd be y minus 5 equals, my slope for my perpendicular line is -4/3 times x minus 6. And that would be it. You would be all done there if you wanted to be. That's the simplest way to do it, and I would accept that answer in a heartbeat. I'll have both forms of the answer on my answer key. The slope-intercept form was always pounded into me, so that's what I always tend to go back to. So we know it would be -4/3 x plus whatever that y-intercept is. We represent it with b. Then you put in the 6, 5 to find b. So 5 goes in for y, 6 goes in for x. -4/3 times 6 is -8. You add 8 to get 13 equals b. So this equation here becomes y equals -4/3 x plus 13. Those two equations are the same. Either one of those is acceptable as your answer. Systems of equations is fair game. Then, of course, word problems. Any questions? With reviewing for the first test, there's an extra credit opportunity that comes up. If you scan and email to me the completed test 1 review, that means every problem completed, and you do have to show at least part of the steps of your work for it. I will give 20 points extra credit. To be totally frank, that's a lot of work for 20 points, but it is still 20 points. That's basically a free quiz. Now, even with the test coming up, remember, homework 5, A, B, and C is still going to be due on Monday. And quiz 5 is also still due on Monday. So this extra credit for completing the test review, I will allow you to have until Friday, the was that March 1st, I believe. So if you have that completed by Friday, March 1st, scanned and submitted, you can get up to 20 points extra credit.
The test 100 points?
The test is 100 points.
Okay.
Just scan it and have it, scan it in and email it to me as an attachment.
Okay.
That's the easiest, because otherwise trying to type it all out is kind of tedious to type math problems, the math work. Any other questions? Okay, well, you guys have a wonderful day. We will see you on Monday for the test. If you have any questions, try to use my WITC email. I will respond to that a lot quicker. I'll try to make sure I'm checking Nicolay every day between now and Monday, but sometimes I get busy and I go a day or two without checking that email. So make sure you try to send it to the WITC email if you can. Okay, you guys have a great day. Have a good weekend. Drive safe.